We use the binomial distribution when we have two possible outcomes, so either win or lose, or success or failure, heads or tails, and the probability of a success is the same for each trial, each time we do it. This question says the random variable x, the squiggly line means is distributed, and b means binomially. The 10 is the n, how many times we're doing it, the number of trials, and the 0.2 is the probability of a success each time. So if we had a bias coin and we're flipping it 10 times, the probability of getting a heads each time is 0.2. So that's our distribution. The question for part A is find the probability that x equals 2. Find the probability that we get 2 heads. We get 2 successes out of the 10 trials. We're going to use a calculator to work this out. So we'll grab our calculator. We want to go to our menu and then find distributions. We want the binomial probability distribution, binomial PD. So find that on your calculator and then click variable. X is going to be 2 for the first question. That's how many successes we want to find the probability of. N is how many trials there are. That's 10. And P, the probability of success, 0.2. And we just type it into the calculator and we get 0.302, or 30.2%. And that's our answer for part A. For part B, we just need to change x into 3. So change x into 3, and we get 0.201. And that's our answer. Here's a question for you to try. See if you can give it a go. So the random variable x is distributed binomially. N is 12. P is 0.3. And we want the chance, the probability that x is 3. So 3 successes out of the 12 trials, with the probability of success for each one being 0.3. So this time, x is 3, n is 12, p is 0.3, and we get 0.240, or 24%. Part B, find the probability that x equals 1. So change x into 1. 0.0712. 0.0712 to 3 significant figures. The probability of a component being faulty is 4%. A sample of 20 components is taken. Define a suitable distribution to model the number of faulty components in the sample. So we're going to use a binomial distribution. So the probability each time is 4%, or 0.04, and n is going to be 20. So we're going to say, let's call the distribution x. X is distributed binomially with n being 20, and the probability each time of success, or the component being faulty, is 0.04. For part B, we're going to use our distribution, find the probability of there being 2 faulty components in the sample. So x is going to be 2. So let's have x as 2, n is 20, the probability each time is 0.04, and we get 0.146. And one question for you to try, see if you can give it a go. So this time our probability is 0.06, and n is going to be 30. So we're going to say our distribution is going to be distributed binomially. N is 30, and the probability of success is 0.06. So we can use a binomial distribution. There's only two possible outcomes, either 40 or not 40. And the probability is going to stay the same for each component. It should always be 0.06. Find the probability of there being one 40 component. So x is 1, n is 30, p is 0.06, and we're just going to type it into the calculator. So 1, 30, 0.06, and we get 0.299.